here, when you open the link and you get here, make sure you add me. Add me in the comments. When you get there, you add me in the comment, please. Okay. When you get here, add me in the comments before we start at all, so that we can begin 5 and 6 today. Okay. So let's begin quickly. So we are starting with theorem 3. You know, the last class we have done theorem 1 and theorem 2. So we're starting with theorem 3 right now. So theorem 3. Theorem 3. Okay. So the well done, sir. Well done, sir. So let's begin without wasting time. Let's begin without wasting time. Now, theorem 3. Please, theorem 3 here. Let's say you have a circle. Listen. Theorem 3 says angle on a semicircle is 90. The angle on a semicircle, is 90 degrees. The angle on a semicircle is 90 degrees. So that is the theorem, understood? The angle on a semicircle is 90. Now let me break it down for you. What is a semicircle? A semicircle is the half of a circle, because semi means half of a circle. Understand me now? Which means that we are going to have a diameter. A diameter is a line that bisects the circle into 2. That's the diameter. Let's see that now. Let's say you have 2, then you have center O. Understand? Then you have a line that passes through that center. So this is a line that passes through the center O. Let me call the line X, Y. You see, we have line X, Y here. We have center O, the diameter. Understood? Now, that means this is a semicircle and this is another semicircle. So we have 2 different semicircles. So now this theorem says the angle on a semicircle is 90. The angle on one of them is 90. Now, how do we know? Where do we know? Where do we place that angle on that semicircle? Now, let me take this semicircle here. You understand me now? Now, taking this semicircle, where is the angle? Will the angle here be here? The angle cannot be here. The angle has to be any place here. Don't get like this is a semicircle. So the angle has to be any point here. Not in this place. It's here. So let me locate the angle to be anywhere. Let me locate this place. Let me call this point A. So that means the angle on this point A will be 90 degrees. Hope you get it now. Now, how will I do it? How will I do that the angle on this semicircle will be 90 degrees? I'm coming, please. I'm coming. Let me drop this link before I continue. Let me drop this link before I continue. I'm coming. Okay, thank you. So let me continue. Now, how do we get the angle on the semicircle? The angle is always 90. So this is semicircle here. So this is semicircle XAY. XAY. That is semicircle. So we draw the shape out. The shape looks like this. You can see semicircle. So this is angle here. Now, what do? Just go to the, this end, this diameter here, the end, XY. That's where you need these 2 points here. And also this point A here. That's where you need. Yeah? You understand now? So this point A here, you just take your ruler and your pencil, draw a line, one to meet X, other one to meet Y. Like the 2 lines must meet your X and Y. So let's draw one for X, the other one for Y. You can see for Y. So this is the angle now on that A. That angle is angle in a semicircle, and that is 90 degrees. Hope you get the point now. So this is angle 90. Let me locate another place again. Still on the same semicircle, any point here. Let me locate any point. Let me locate this place. Let me call it point B. What will I do? Go back to your same XY, the end, and go to your B. One line will come to X, the other one goes to Y. Like one must go to X, one goes to X, other one goes to Y. You can see now. So the angle on that B is 90 degrees. You can see. So any points you locate here, just join into this XY. To this XY. That angle must be 90 degrees. Hope you get the point now. Okay, welcome. Amata, Cynthia, Orekoya, welcome. Welcome. Let me greet you. Welcome. Welcome, Orekoya. Welcome. I can hear you just welcome. So let's continue. So hope you get the point here now. Hope you get it. Now let me locate the other semicircle. Let me locate the second semicircle. We said the angle on the semicircle is 90. Now this is your diameter. Your diameter. You can see that pass to the center. Now locate any point you like here. Let me locate this place. Call it point P. Let me locate this place again. Call it point Q. You can locate any point from here to here. Now what will I do? I will just go to that point, join it to my XY from the point here. One to Y, other one to X. 2 lines. So one goes to X. One goes to X. You can see. The other one goes to Y. You can see now. So the angle is on P. That angle is 90 because it's angle in a semicircle. Let me locate it here also. What will I do? I will do the same thing. Join it from that Q. One to Y, one to X. Always join it to that diameter, to the end of diameter. You understand? Anything you are doing to the diameter, to the end. So let me point from here to my X, from here also to my Y. The angle is also 90 degrees. You see now? So that's how to know angle on a semicircle. And the angle is always 90 degrees. And Grand Crimsey, welcome. Welcome, Grand Crimsey. Welcome. So let's continue. So hope you have gotten the idea now. That's angle on a semicircle, and it's always 90 degrees. Hope you get that. Okay. Now, I haven't known that. Let's go to should I give you more examples there? Okay, let me take theorem 4 also. Theorem 4. Understand? So after theorem 4, I will take some examples, understand, concerning theorem 3 and theorem 4. You can take your pen and you can put it down. You can take your pen and draw this before I clean. You can draw before I clean it. Draw before I clean it. Okay. Now let's go to theorem 4. Theorem 4 now. Theorem 4. So I'll write it for you. Theorem 4 says angle on the same segment are equal. Angles on the same segments are equal. The angles on the same segments are equal. Let's do that. The angles on the same segment, angles on the same segment are equal. The angles on the same segment are equal. Please make sure you ask your question. If there's any place you don't understand, kindly ask your question. You can take your pen and put it down. Kindly ask your question if there is any place you don't understand so far. Kindly ask your question. Okay, now 24 says the angles on the same segment are equal. Now, what do you mean by the word angles on the same segment? When I say angle on the same, what does it mean? Let me explain to you. Angles on the same segment. Let me explain it to you. Now, let's see. When you say same segment means angles that come from the same arc. Like people bear the same surname in a family. You understand now? So all the people in that family, they bear the same surname. So that surname is like where all the names come from. You understand now? So angles on the same segment are equal. All the angles that come from the same arc, from the same source. That means all the angles come from the same source, the same arc. The same arc subtend those angles. You understand now? So we now call it angles on the same segment are equal. They are angles that all come from the same source. They all come from the same arc. Hope you get that. So let me explain it here from with a diagram for you. Let me explain with a diagram for you. Now let's see. Let's say I'm coming. Let me put it everywhere. Let's say we have an arc. This is an arc here. Let me call this arc PQ. Arc PQ. This arc PQ. Let me use a green marker or a red marker to pull that. Arc P. Let me this arc PQ. Arc PQ. Arc PQ. You can see that. Arc PQ. Now this arc PQ wants to form different angles. This is my PQ from here. This is also my PQ. So this arc PQ wants to form, let's say three angles. So let us look at this PQ. The first angle is here. The first angle is here. The second angle is here. The third angle is here. So let me call this one point A, call this one point B, call this one point C. So arc PQ wants to form three angles. One at A, one at B, one at C. All of them are all on the circumference. No angles here at all. Understood now? So we have arc PQ forming three angles A, B, C. I can put my D here, E here. I can say A, B, C as far as it's from here to the other side here. Understand now? So what will I do? I will do the same thing that I've been doing. For this point A, I will always join, this A now. All this angle here must come from the same arc. You understand now? Because they are angle on the same segment. They have to come from the same source. So all this A, B, C, they must come from the same arc. So just be checking the end of the arc. PQ, the end. PQ. So for A, you join it to your P and your Q. For B, join it to your P and your Q. For C, join it to your P and your Q like that. So let's do it for A. A goes to P and also goes to Q. You can see. So this is the angle. You can see this is the angle formed by this arc. The arc is forming this angle. You see now? Same thing goes for P. Join it to your P and Q. Join it to your P and your Q. So this is the angle on B also. You can see one on A, one on B. You can see now on B is going. So it goes back to the same arc PQ. Same thing goes for C. Join it to your P and to your Q. You can see this angle here. You can see traces, the angle, same angle, come from the same PQ. So all these three angles come from the same PQ. Therefore, they are called angle on the same segment and they are equal. Understood? They are always equal to themselves. Hope you get that. They are called angle on the same segment and they are equal to themselves. Note it. So if this, let's assume this angle is angle 80 degrees. All of that ones too must be 80 degrees because they all come from the same arc PQ. Hope you get that now. That's how we explain angles on the same segment. Now, how do we represent this? How do we represent? You can take your pen and put it down. Put it down before we continue. Put it down. I'm calling. Send this thing to some people. Let me send this thing to some people here. Okay. Okay. So hope you have written it down. Have you written it down? So I hope you have written it down. So now let's look at how we can represent this. How can we represent all this? Let me explain how we can represent this. Now let me come back to theorem 3 and let me explain how we can represent it. Now look at it. This angle 90, angle 90. How do you represent it? Check your 90. Check the two lines that forms it. Trace it. It goes all the way to where? X and Y. See, to X and Y. That is this angle will be what? X, Q, Y. Look at it. X, Q, Y. X, Q, Y. That's the angle is on Q. So that means you can say angle X, Q, Y, where the angle is on Q, you can see. That means angle Q equals to 90 degrees. You can see. Same thing goes here. X, P, Y. You can see. X, P, Y. X, P, Y is also equals to what? 90 degrees. You can see. Okay, after is it 180 or 80? Where? No, it's 80. It's 80. It's 80. It's 80. It's 80. Amaka, it is 80. It's 80 degrees. 80 degrees. Okay, so this XPY is 90, you can see. So how do you represent this one too? X, A, Y. X, A, Y. The angle is on A, so that's 90. So we have X, A, Y. The angle is on A. It's also equals to 90 degrees. So how do you now represent this one too? X, B, Y. X, B, Y is on B. So X, B, Y also, where is on B, is also equals to 90 degrees. Can you see now? That's how we represent. So how will we now represent this one now? How will we do this now? This is what? P, look at the angle A, Q. See, P, A, Q. So angle P, A, Q is equal to what? 80 degrees. What about this one? P, B, Q. P, B, Q or Q, B, P. Anyone? Q, B, P or P, B, Q. So P, B, Q is also equals to 80 degrees. Can you see? What about this one too? P, C, Q is also 80. P, C, Q is also 80 degrees. Can you see now? So 3 of them are all 80. And what is the theorem? Angles on the same segment are equal. Angles on the same segment are equal. That's it. For this one, that's what angles on a semicircle. This one is angle on a semicircle are equal. You can see. So that's theorem 3 and theorem 4. Theorem 3 and theorem 4. Okay, Orishi, you are the one. How are you? Okay, dear. Okay, you are the one. So that's for theorem 3 and theorem 4. If you are just joining, just make sure you back the video, you put it back, so you start, to listen to it gradually till you get to where we are. Understood? But when you get to the class, make sure you write your I. You can eye me on the chat. Now let's take 1 or 2 examples. Let's take some examples as regards theorem 3 and theorem 4 before we now go to theorem 5 and theorem 6. Understood? Let's see. Hope you are written this down. Okay, let's see. So let's take general examples regarding theorem 3 and theorem 4 now. Regarding theorem 3 and theorem 4, let's take some examples. So let's take some examples. And let's look at the first example. You have a circle. You have a circle. And then you have something like this. The O. So we have A, we have B. And then we have something like this, and like this. Let's say we have your C and we have your D. So you have like this. Yeah. You have this like this. And you have this place as you have as 70 degrees. 70 degrees. And that's what you are starting in. You have A at 70 degrees. 70 degrees. And you're asked to find 5x. Now to find x. Find the value of x. So in this question, we are asked to find x. So how do you find x in this question? How do you find x in the question? So let's look at it. How do you find x in the question? So please, when you get to class, kindly drop your I. I mean, so on comments class. Let me know that you are here with me. Understood? Okay. Now let's find our x here. Let's find our x in this question. How do you find x? Let's look at it. Now, firstly, go back to your theorem 3 that I just taught you now. Go back to your theorem 3 where I said you have a circle, you have a center O, and you have a line passing through that center. Now, listen, once you have a line passing through center O, which is called a diameter, the line is called a diameter. Once you have a diameter, just check your question. Which line do we have here passing through diameter? Sorry, passing through center. Let's see. Look at this line AB. Line AB is passing through center, just like this center O. That means line AB is a diameter. Now, once you have that kind of line, that means it is possible you apply theorem 3 that says that angle on a semicircle is 90. Why? Because a diameter will bisect a whole circle into two semicircles. First semicircle and second semicircle. Now, angle on a semicircle is 90 degrees, which means that whenever you will see a line passing through center, which is a diameter, therefore we are going to have a semicircle. An angle on a semicircle is 90. So if you have a question and you see a line passing through center, such as this line AB, passing through the center like this, then it's likely we apply that theorem that says angle on a semicircle is 90. Now, closely look at this diagram here. Look at this diagram closely. Look at it. Look at it. This is the diameter. We have another line here, but the line is not passing through this center. Therefore, it is not a diameter. So we only have line AB that is a diameter. Now, look at it very well. Line AB. You can see. Then we have D here. We have D here. So we have, look at that point D here. Now, trace the lines, the angle that form that D. Look at the angle. Do this angle here. Trace the two lines. It goes to A and B. It goes to AB. Now, let's do the same thing here. The two lines, one goes to A, the other one goes to B. You remember what I told you? I said this angle will be angle 90 degrees because this is a diameter. Therefore, this is a semicircle. An angle on a semicircle is 90. That point trace it to that end of diameter. That's 90. So therefore, from here, this angle here should be 90 degrees. Don't mind this line. Don't let this line confuse you. Understood? The whole angle here, see, one that goes to A, one that goes to B. So the angle here should be 90 degrees. And that's what you write first before anything. Now, okay, this angle, which is angle what? ADB. Look at it. ADB. You can see. Angle ADB is 90 degrees. So that's where you start from. Understood? So let's look at that. Angle. So let's look at it. Solution. Angle AD. Sorry, let me apply this one. Angle ADB, and that's on D. It's on D. This angle here is always 90 degrees. Why? Angle on the semicircle. This semicircle here. So we say angle. This symbol of angle. Angle on a semicircle is always 90. Now, once you know that this place is 90, now look at this one also. For theorem 4, you remember theorem 4. Look at these two angles here. This angle here and this one. The shape is like W. Look at it. Look at it. So look at these two angles here. This one, this one. Look at this. Trace it down. It comes to BD. Look at it, to BD. Trace this one too. To the same BD. Therefore, two of them are angle on a what? Angle on the same segment. The way I thought that I said, when you have two angles coming from the same source, therefore their angle are on the same segment. So therefore, these two angles are equal. Their angle on the same segment. Hope you get that now. So that means if you take 70, this place is only 70. So how do you write it? You say okay. You say okay. Look at it here. This place is 70. This place is 90. You can see. So how you write it? Okay, this angle, which is angle what? BCD or DCB. Anyone you have it. So angle BCD, which is here, is equal to angle BAD, which is this, and they are 70. So angle BCD, this one, angle BCD must be equal to what? Angle BAD. Angle BAD. That is angle on C. Is equal to angle on A, and they are both what? 70 degrees. What's the theorem? Angle on the same what? On the same segment are equal. The angle on the same segment are equal. Angle, this symbol of angle, angles on the same segment. Oh, we get that now. So therefore this is 70. Now, once I've gotten A at 70, look at this triangle. Triangle ABD. Look at the triangle ABD. Draw it out. From triangle ABD, from triangle, this symbol of triangle, triangle ABD. You can see, you can draw it out the way it is. Draw it out the way it is. Triangle ABD, the way you can see, we have 70 here, we have 5x here, and we have 90. You can see your 90, see, from here to here, angle 90 degree. You can now use the sum of angles in a triangle. You can see the triangle here is always 180. I hope you know the theorem. That whenever you have a triangle and you add all the angles inside it together, you must get 180. So you can say 5x plus 70 plus 90 equals to 180. So let me put my A back, my A, B, and D. So let me see. So we have 5x plus what? Plus 70 degrees plus 90 degrees. Everything must equal to 180 degrees. What is the theorem? The sum of angles in a triangle. You can say the angles in a triangle. The angles in a what? In a triangle. You can see. You just solve the equation and get your answer. So let's solve it like, so we have 5x. What's 70 plus 90? That's plus 160. The 2 must equal to what? 180 degrees. Then we have what? 5x equals to 180 degrees minus 160 degrees. We have 5x equals to what? 20. And x equals to 20 all over 5. So x equals to 4. Our answer is 4. The value of x here should be 4. You can see. Very easy and simple. So look at it again closely. If you have any question, drop it in the comments. Ask me in the comments if you have questions. So let me give you 2 minutes to copy it down. Let me give you 2 minutes to copy it down. Okay, are you done? I hope you are done with it. Okay, so let's look at another example. Let's look at another example, example 2. Let's look at example 2. Okay, let's look at this. Okay, so we have A, we have B, we have C, we have D, we have here as 25 degrees. We have here as 5x. Okay. We have to find x and find angle ADB. Let's find x and find angle ADB from here. So let's find these two. Find x and find your ADB. Kolawole Akinwale, you are welcome. 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 Kolawole Akinwale, you're welcome. Welcome, Kolawole Akinwale. So let's continue. So look at this question here. We have to find x and we also have to find ADB. You know, we have done Theorem 1 and Theorem 2 in our previous class. We've done it. Now this is Theorem 3 and Theorem 4. Most time in circle geometry, one single question, you can apply 3 or 4 theorems in a single question. You understand? So this is the reason why you have to go and watch that. My previous live video is there on my channel. Go and watch it there for these theorems. But let's look at this one and let's work it together. So welcome. So let's see. Now, look at this diagram here. Normally, if you see this kind of shape like W, something like this, or M, look at it now. M. You can see your M, like you can see. So there, it means it's likely you use angle on the same segment. Look at it now. Look at this. It's coming from here. Look at it also. It's coming from the same place. So this angle is coming from AB. This one is coming from AB. So therefore, they are equal to themselves. That's angle on the same segment are equal. Now, from our previous class, I did Theorem 2, whereby I said the angle at the center is always 2 times the angle at the circumference. You remember, the angle at the center is twice circumference. Just make sure that the 2 angles at the center and circumference, 2 of them comes from the same arc. You understand me now? Let's look at it here. Look at this center. Where is center? This center here. This angle at the center. You can see center O. This angle at the circumference. Let's check if 2 of them are related. Trace your angle at the center. Trace it. Look at it here. Trace those 2 lines. It's come from the same AB. From the same AB. Trace angle as circumference. Trace it from the same AB. Therefore, this angle here and this, they are related by 2 times. That is, angle at the center is twice angle at circumference. Understood now? Let's look at this one and this one too. Let's check. Your angle at center comes from AB. Check this one too. The 2 lines. Trace it from the same AB. Therefore, they are also related. So you just apply the same theorem that angle at the center, the angle here, will always be 2 times of the angle here. If the angle here is 100, this one will be 50 because 100 doubles 50. If the angle here is 40, this one will be 80 because 40 times 2 is 80. So if you are given this angle here first, and you have to find this place, you multiply this one by 2 to get your 80. But if you are given this one first, center, and you are finding circumference, you divide it by 2 to get this one. Just know that this one is always more than this. You can see the way those theorems are related. Mr. Tobi Alabi, welcome, sir. Welcome. Welcome, sir. So, hope you get the point. Hope you get that. So, once we have known that, it's very easy for us to continue now. So, let's see. Let's see. So, now don't forget that whenever you draw a circle, look at it, you draw a circle. If you draw a circle, now, you know, normally this line is called radius. This is radius, another radius. You know what I mean now? If you join this place, that is a triangle. You remember isosceles triangle is a triangle that has two sides equal. So you know that this R and R are the same. Of course, they are equal. In this 1, 2, 3, so these two are equal. Therefore, this triangle here, look at it here. This is my center O. This is my radius. Anything you draw from O is your radius. Then this is a complete triangle. Therefore, triangle AOB is an isosceles triangle with your equal radius. That's when they put this kind of thing. This stuff here. The radius are equal. And whenever the radius, the left leg and right leg are equal, then just look at the base also, the base angles. The angles that are down are also equal, like this. You can see, if the sides are equal, the angles also that are base means down, are also equal. If this place is 80 degrees, this also must be 80 degrees, same thing. Therefore, these two angles are equal, 25. So 25, this place is 25, they are also equal. From isosceles triangle, the theorem here is base angles of an isosceles triangles are equal. So no one will tell you that this triangle is isosceles, but because of the radius, the two radii are equal. Therefore, these two angles are also equal. So what I'm going to say is that this angle here is also equal to this angle here, 25. That's the next thing, the first thing you say. Understood? So how do you write it down? You say, okay, what angle is this? Angle, let's trace it. Trace the line. It goes here. So that's angle what? You can start from here. DAB. That is DAB. So it's cut on this A. So you can say angle DAB, and it's on A. So the cap is on A. This angle here must be equal to this angle here also. Must be equal to the one here. And what angle is this? You can say OBA. You can see OBA. It's equal to angle OBA. You can even call this one angle OAB. Don't use D, use this one, OAB. So OAB, which is this one, is equal to OBA, this one. And two of them are equal to 25 degrees. You can see. So let me put the green marker there. This is my 25 degrees. Green marker, 25 degrees. So what theorem is that? The base angles of an isosceles triangle are equal. So let's see. That's the theorem. Don't forget, always put your theorem. The base angles of an isosceles triangle are always equal. So they are equal, 25. Now, once you see that these two angles are equal, and this is the triangle, why not quickly find the third angle? By using sum of angle on the triangle is 180. Out of 3 angles, we have 2 angles. That's this plus this, 50. So the main what? The main, you just say 180 minus that 50, you get the remaining one here. That's 130. Is that also? That's angle 130 degrees. So just say this angle here, you can say from triangle what? Triangle OAB. From triangle OAB, you can just draw it out. We have O, we have A, we have B. This triangle here. This is my 25. My second 25. So how will I get this place? I will say this angle here, angle O plus angle A plus angle B. O plus A plus B must give me what? 180 degrees. What's the theorem? Angles in the triangle. You can see that for everything I'm writing, I'm putting the theorem here. Very important. Angles in a triangle. So that's what? O plus 25 plus 25, that's 50, equals to 180. So O equals to what? 180 minus 50, that's 130 degrees. So my angle O is 130 degrees. So this place is what? 130 degrees. That's my O, 130 degrees. You can see 130. So since I've gotten that, please don't forget, as you are joining the class, make sure you eye me. Let me see that you are in my class. You eye me once you are in my class. Okay, so let's continue. Let's move on. So from there, what do we do? Since we have gotten this one, you can see we are trying to get this one by one, until we get to x, because the question says find x. Now, how do you get x? Don't forget the theorem I told you. Look at it. Once we have seen one angle at the center, O, and the other one at the circumference, C, then they are related. I told you before, just the angle at the center is twice circumference. Why? Trace it and check if they are related. If two of them come from the same arc, same source. Let's check. Check your center. These are the two lines for the center. It's come from AB. Check your circumference. The same AB. Therefore, you can now say this angle here is twice of this. So you can just say, okay, this angle, what angle is there? Angle AOB. AOB is on O. So angle AOB, which means the cap is on O, which means O, that's 130, will be, this 130 will be twice of this angle ACB, this one, ACB, here, of ACB, where the cap is on C. Understood now? What theorem is that? Angle at the center is twice angle at the circumference. The angle at center is what? Twice the what? Angle at circumference. Note it. So this one we are going to follow. What's my AOB? 130. Follow it. 130. This one now, 130. This angle is equal to what? 2 times, what's your ACB? 5x. Your ACB is 5x. So times 5x. You see now? So just solve this question and get your answer. That's what. Let me clean this place. Hope you have copied this. Okay, let me see if it can contain that place. Can this contain it? Coming. Okay, let me see if you can contain this place. Let me see. So just say 130 equals to 2 times 5x. From there, just solve this equation, solve it and get your results. So let's solve it. So 130 equals to what? 2 times 5x is 10x. So x equals to 130 all over 10. And that is what? That is 13. My x is 13. So I've got my x as 13. So which means that since my x is 13, 13 times 5 is 65. That means angle ACB is 65. Therefore, angle ACB, the cap on C now, on C, this place, ACB, C. This what now? Is 13 times 5. And that's what? And that's 65 degrees. So that means the angle here is what? Is 65 degrees. 65 degrees now. You can see. So once this place is 65 degrees, we can get this one too. And that's what we have to find second one. You're welcome. It got so wonderful. Welcome. Welcome, wonderful. Welcome, wonderful. You're welcome. Wonderful, you are welcome. Welcome, wonderful. So let's see. So let's finish it quickly. So your ACB is 65 here. ACB 65 now. So we are asked to find ADB. Let's trace it. ADB is cut on this. So we are finding here, this place here. So since this place is 65, what is this place? I've told you that the two of them all come from the same, this one, look at the two lines, come from AB, this one too, come from AB, so they are angled on the same segment because they are both on the circumference and they are always equal. So 65, therefore, this one is what? 65 degrees. How will you say it? Angle ACB, angle ACB, which is this one, is the same thing, equal to this one, that's ACB, ADB, equals to ADB, and two of them are what? 65 degree. What was the theorem? Angle was on the same segment are equal. Angle on the same segment are equal. Angle on the same segments are always equal. Hope you get that. So that's how we get. So we have gotten our angle x. Our x is what? 13, and our ADB is what? 65. So therefore, our x is 13. So x is 13, and ADB is what? 65. Because we have gotten the answer. You can see, very simple, as that. So you can copy it down. Copy it down in 2 or 3 minutes, or you can screenshot it before we now move to Theorem 5 and Theorem 6. Quickly. So, are you done copying? You can also screenshot it or copy it. So let me give you 1 more minute to screenshot or copy. Okay, are you done copying it now? Okay, since we are done, let's go to Theorem 5 and Theorem 6. Theorem 5 and Theorem 6 now. Theorem 5 and Theorem 6. Okay, so then 5 and 6 now. So then 5. So then 5. Okay, so then 5 says the opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. Now, what does supplementary means? Supplementary angles are angles that add up to 180 degrees. When two angles add up to 180, those angles are called supplementary angles. Understood? So, opposite. Now, what's a cyclic quadrilateral? Of course, a quadrilateral comes from the word quad. Quad means four. Four. So a quadrilateral is a plane shape that has four sides. Four sides. For example, a square. Square has four sides. Rectangle has four sides. Rhombus has four sides, and so on and so forth. Now, cyclic means circle, like circle. So if you draw your quadrilateral inside a circle, such that the vertices of that quadrilateral, the end, those tips, those corners, touch the circle at the circumference. You call it a cyclic quadrilateral. Let me explain to you. Let's say this is a circle. Then we have a four-sided shape. Let's say 1, 2, 3, and 4. So let's call this one point A, call this one point B, call this one point C, and call this one point D. So 1, 2, 3, 4. 1, 2, we have four-sided shape. Inside a circle, that four-sided shape is a quadrilateral. Cyclic means inside a circle. Opposite angles mean any angle facing each other. Look at this angle here and this angle here. They are facing each other. You can see. Therefore, they are supplementary. When I say opposite, face me, they are facing each other. Now, when you add the two together, you must get 180. That's what we call supplementary angles. Understood? So this angle here must be added up to 180. The same thing here also. This one also, they are also facing each other opposite. They must also be supplementary. They must add up to 180 degrees. Understood? Now, let's look at this. This angle is angle. What angle is this? Angle BAD. You can see, look at the two lines that form it. So angle BAD, where the angle is on A, this place, plus what angle is this? Angle BCD, plus angle BCD, you can see is on C. So if you add the two together, you must be able to get what? 180 degrees. You can see. Same thing here also. What angle is this? Angle ABC. This angle. So angle ABC, the cap is on B, plus this one, that's angle ADC or CDA, anyone. You can see the two of them now. Angle B plus angle D must also be equal to 180 degrees. So that's what the theorem is talking about. Understood? Now let's assume this place is 100 degrees. What will this place be? 80 degrees, because 100 plus 80 is 180. Let's say this place is 110 degrees. This will be what? 70, because 110 plus 70 is 180. Understood? So if you have this kind of scenario here, don't forget your center O, forget it. So add together 180, add together 180, and you are good to go. You can see. So draw it down, and write it, or you can screenshot it. Okay, so hope you are done copying it. Hope you are done copying it. So having known that, let's go to theorem 6. No, let me take example on this theorem 5 before we go to theorem 6. Examples. Examples. Okay, example. Let's say we have this circle. We have something like this, your center O. Let's say this is X, this is Y, this is Z, this is P. So your center O is here. And we have this place as 100 degrees. So we are asked to find this place. The question says find angle PZY. Find PZY. We are asked to find PZY. Let's find PZY from this question. Find PZY. So let's see. Now, one thing about circle geometry is that you can use any method, any theorem, and still get the same result. So I will use two different methods, and you see that all the theorems are together. Hope you get that. So let's see. Solution. Now, first and foremost, let's see. Look at this angle here. This angle at center. This angle at circumference. Angle at circumference. This one is angle at circumference. Because see now, this circumference is on circumference. This one is on circumference. So what do we do? Let me use the first method. You know the angle in my previous theorem, I said that's theorem 2. I said angle at center is always twice angle at circumference. But you have to check if two of them comes from the same source, from the same arc. Let's check. Trace this angle out. Trace the two lines, the angle at center. The two lines come from where? From PY. From PY. Trace angle at circumference too. It's come from the same PY. Therefore, angle at center is twice of this. So if this place is 100, then this one is what? 50. Because we're going to divide 100 by 2. That's 50. That means this angle is 50. You can see. Now, if this angle is 50, what is now this angle that we are asked to find? Find PZY. Find PZY. We are finding this angle here. So what is it going to be? Now, don't mind this 100. Neglect. Let me cover it. This 100. This is cyclic. You can see 1, 2, 3, 4. Cyclic quadrilateral. And the theorem here is that any opposite angles on the point on the circumference, if you add them together, you get 180 from this theorem here. So if it is 50, then this place is what? 180 minus 50. That's 130. That's the answer. Our PZY is 130 degrees. You can see that's 130. That's all. That's using method 1. Using what? Method 1. Using method 2 now. Okay, let me write that first. Let me do that first. Let me use that. Let me do that. Let me do that. Because we have to know how to write it down. You need to know how to write it down. So we are doing theorem 5. We are in theorem 5. Theorem 5. So solution. Method 1. So this is 100. This is what? 50. How will you write it? What angle is this? POY. POY or YOP. POY in this place. Angle POY. Angle POY, which is this place, will be 2 times of angle. What angle is this? PXY. PXY of angle PXY. 2 times of angle PXY. What's the theorem? Angle at the center is twice angle at the circumference. That's the theorem. So we have the angle at center is what? Is twice the what? Angle at circumference. You can see that's the theorem. So follow it. What's POY? 100. Put it there. 100 is equal to 2 times our PXY. P 2 times PXY. So collect like divide both by 2. Your PXY now, PXY will be what? 100 divided by 2. 100 divided by 2. And that's what? 50 degrees. So your PXY is 50. That place is what? Is 50. You can see. So once I've gotten that place, don't just neglect this place. Focus on your cyclic quadrilateral. So that's 50. So that's 180 minus 50. Because opposite angles of the cyclic quadrilateral are always 180 degrees. So that means this angle PZY here, angle PZY, if you add it together with this angle PXY plus angle PXY, you get what? 180 degrees. What is the theorem? Opposite angles of a what? Of a cyclic quadrilateral. Hope you get that. So now let's follow it. Our PZY, which is here, will now be what? That's 180 minus our PXY minus 50. So our PZY is what? 130 degrees. So our answer is 130 degrees. 130 degrees. You can see. So that's the result. 130 degrees. That's theorem 1. That's method 1. Now let me use second method. Method 2 now. Let's go at method 2. Okay, let me work it here. Alternatively, you can do it this way. Method 2. Method 2. You can say, okay, let me clean it back. Now, let's look at it. This is angle at center, 100. This angle, this is directly angle at circumference. That's this place. So we are asked to find angle at circumference. But don't say, angle at center is 100, then angle at circumference will be what? 50, when you divide 100 by 2. If you do that, you are wrong. Though you got it theorem right, but you are wrong with why? Look at it. Did not follow same pattern. Look at angle at center. It's facing down. See, it's facing down. Look at angle at circumference. It's facing up. So they don't follow same pattern. They both have to face the same side, or same pattern. Look at this one pattern here. Look at the angle like this. Look at this one like this. They are opposite, and it shouldn't be. They have to be maybe like this. Same pattern. You see now? So note that. So therefore, we can't use that. Now, what we're going to use is that instead of using 100, why not use 100 in the other side from here to here? Sorry, let me use my red marker. Why not use from here to here? It is still on O, but it is reflex of that O. Reflex angle is the bigger one here, O. And you know, since this place is 100 degrees, we can get this place because the old angle at the point is 360. So 360 minus 100 gives us 260. So this is 260 here. So you can now apply 260 center and this one. See now, same pattern. Same, you can see. They are facing each other, you can see. You can say, okay, the angle at center, 260, will now be 2 times of this place. And if this place is 260, then here will be 260 divided by 2. That is the same 130 that we arrive at here. You can see. So that's the second method. So you can just write down yourself. Understand now? But mind you, this angle is reflex. You say, okay, reflex, this is POY. But it says reflex PO. Let me work it. Reflex POY, reflex angle POY, which is this place, will be what? 360 minus 100. And that's what? That's 260 degrees this here. What is the theorem? Sum of angles at the points. Everything is sum of angles at a point You can see. So you can now say, okay, this place might be twice of. So therefore, PZY, this place, your PZY here. So therefore, my PZY will now be 260 degrees that we have here all over 2. And that's what? 130 degrees. Same answer. What the theorem? Angle at center is twice angle at circumference. Angle at center is twice angle at circumference. And then you are done. You can see. So we still got the same 130 here and here. So that is the result. Hope you understand. So kindly put it down, and let's go to theorem 6. Now, after that theorem 6, probably in my next class, we will now take general past questions concerning WAEC, NECO, GCE, JAM, IGCSE, SAT, concerning circle geometry after this. Understood now? So write this one down and let's go to theorem 6 quickly. Write it down. Okay. Hope you have finished it. Okay, I haven't done that. Now let's go to theorem 6. Theorem 6. Okay. Theorem 6 now. Theorem 6. Let me check my time. Okay. We have 14 minutes more. 14 minutes to go. Now, theorem 6. You can write it down. An exterior angle of a cyclic quadrilateral is equal to the opposite interior angles. An exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. Let me show you. Let's say you have a circle. So the same cyclic quadrilateral. So four sides, 1, 2, 3, and 4. Your center O, don't forget it. Now, you know, your angle can be interior or exterior. You know that? Interior angle or exterior angle. Interior angle is the angle inside, while exterior is the angle outside. Understood? Now, let's locate any opposite angles. Any opposite. Let me locate this one and this one. Opposite angles. You can see now. So, any opposite angle you have, one must be exterior, the other one must be interior for any opposite. Now, let's make sure be exterior. Then we produce this line out like this. You can see. So, this is the exterior, the one outside. This is exterior outside. This is interior inside. So, the exterior angle here, let me call this angle x degree. The exterior here will be equal to the opposite interior here, xx. So the interior here will be same thing as the exterior here. Understood? So that's what we are talking about. The same thing happens here. Another opposite angle also now. Let's make sure the interior will be equal to the opposite exterior. So if this place is y, interior, the opposite exterior also will be y. That's what we are talking about. And that shape must be a cyclic, that circle, quadrilateral. The vertices must be touching the circle, not like this. Some students will draw like this. No, you don't draw that way. Those ends must touch this point, must touch the circle at the tip end. Understood? So that's what we are talking about. That's the theorem, theorem 6. So note that. Let's take examples under it. Let's take an example under that theorem 6. Okay. Example. Oh, let me change this. Example. Look at this circle. We have center O like this. We have one this way. And we have one like this. Okay, let's say you have this like this. This way you have O here. Then you have your this as we have like 95 degrees. And you have to find this place. You have to find angle, let's call it x. Find angle x. Now, how do you get your x here? How do you get your x in that shape? Let's look at it. Solution. So let's look at it. Solution. Theorem 6. Now, what do we do here? Sorry. This is a cyclic. Look at it. You have to watch it very well. 1, 2, 3, 4. 1, 2, 3, 4. Don't start from this center. Don't say 1, 2, 3, 4. Although this is also a quadrilateral, but the tips must touch the circle. First one is touching circle, second one, third one, but this one is not touching, it's at the center, so it's wrong. So it must be this 1, 2, 3, the one touching circle, and 4. 1, 2, 3, 4. That's a cycle. Understood? So which means that if I cover this place like this, that means this is the opposite angle, this and this. And if you add them, it was 180. And from the theorem 6 we just did now, I said the exterior angle will be equal to opposite interior. You remember 1, 2, 3, 4. So this place is 95 degrees from that theorem 6. Understood? So how do you write it down? Let me call this place to be, okay, this is also what? 95 degrees. Since there is no letter here to, represent it. So that theorem is what? And x. Okay, let me call this place angle Z. Let me call this place Z. Let me call this place P. And let me call this place Q. So that means angle Z equals to 95 because of 1, 2, 3, 4 cyclic quadrilateral. So the exterior angle equals to opposite interior. Don't mind this one because it's at center. So this and this. So I will say Z equals to 95 degrees. Z equals to 95 degrees. What is theorem? An exterior angle of a cyclic quadrilateral, this exterior is equals to opposite interior angle. You can see interior angle. So Z is 95. So your Z is 95. Now, since your Z is 95, we are finding X. You can do it in many ways. You can say, okay, you can say angle at circumference is 95. Now your X is angle at center. Circumference and center. Now you have to check if two of them are related. Let's check if two of them both come from the same arc. Let's check. Check your angle at center. Check the two lines. Trace it down. It comes from this arc here, from here to here. Check angle at circumference also. Circumference. Check it. Trace it from the same arc. Therefore, you can say this is twice of this. But you have to know that they must follow same pattern. Look at the pattern of this one. Like this. Look at this one. They are not same pattern. So therefore, you must say, okay, this place and this place are not related. Instead of using this one inside, why not use the exterior outside? Look at it. From here to here. Don't let this one to confuse you. From inside, from here to here, cannot work. Use the one from outside. So that center, circumference, same way. Center, circumference, same way. And you know that all the angles here at the point must be 360 degrees. So out of 360 degrees, we have our X here. So the remaining one will now be the whole 360 minus X gives us the remaining one here. And that's 360 minus X. So just say, okay, you cannot say, okay, angle at center is 360 minus X. Angle at circumference is now this Z here, 95. So you cannot say angle at center is twice of angle at circumference. That is, the angle at center, that's what 360. Angle at center is equals to is 2 times, angle at center is 360 minus X. Angle at center is 2 times of angle at circumference. You can see now, friends. So write the theorem down. Angles at center is twice angle at where? At circumference. You see, so it can become an equation. Just solve the equation and get your X. Oh, you are welcome. Joel Osas, you are welcome. Joel Osas, you are welcome. The network is bad. I think it's from your side. Maybe from your side. Network is very good here. Maybe it's from your own side. The network is very good here. Try to check your network very well. Amaka, Olushi. Check the network from your own side here. Check it from your side. The network is very good here. Please check very well from your side if it's good or not. Network is very good here. Understood. Okay, so now let's continue. So we have known that okay. So since we have gotten our equation, we just have to solve the equation and get our x, and that's all. So let's solve the equation and get x. So let's solve it. We have 360 minus x equals to what's 2 times 95? That's 190 if you multiply with degrees. So let's collect like terms. 360 degrees. When this 190 comes here, jump equals to and come here, that's minus 190 equals to this minus x comes here and become plus x. That's x. So subtract 170 equals to plus x. So x equals to 170 degrees. So our x is 170 degrees. You can see that's the result of getting our x. Now you can also do it this way, or once you get here 95 and you are trying to get your x, just say okay, you know this is a straight line. An angle on a straight line is 180. This 95, you can quickly get the remaining one here. That's 180 minus this. That's 80. Is it 85? 85. You can see angle on a straight line, two of them. So this is 85. You can now say angle at circumference is 85. Then angle at center will now be 2 times x. See now, angle at center, this one. Angle at circumference, this one. They both come from the same source. Check it. Angle at center, x, trace it. It's come from here. Check your angle at circumference too. Come from the same place. And if you can see that 2 of them have same pattern, you can now say, okay, x angle at center will now be 2 times of angle at circumference. You can see, and that's what x equals to what? 170. If you can get the same, you can use any method and still get your answer. You can see, very simple and easy. So take your time. In 2 minutes, put it down and let me give you some exercises to try. So put it down. Please ask your question. Okay, Joel, you say you don't understand very well. Which part? Which part do you don't understand? Which part here? Joel or Sarah, so you have been here. Okay. Which part here? Joel or Sarah, which part do you don't understand? Which part? Let me know the part so I can re-explain again. Please, if you are with me, this is a mathematics class. Don't leave the class. Try and stay with me. Check through it, rewind it, check through it. Make sure you don't just go and because this is a math class. You can make mistakes easily. You understand now? Make sure you sit down and listen very well. Because you can see that we are putting a lot of theorems. We are doing it. So please, okay, let me know where you don't understand or SARS. Where? Just type it out. The first diagram and second diagram. Where is that? Let me check it. On which theorem, please? On which theorem? Which one there? The first and second diagram. Which one there? On which example? Is it on theorem 6? Is it on theorem 6? Is it on theorem 6? You are not talking, no. Anyway, so hope you have copied it. Okay, let me give you some class work to do. So let me give you two questions here. You do it for me and you drop your answer for me on this in this comment box. So let me give you some class exercise to do. Hello, as you are here, as you are watching it, there's a button there called the subscribe button. Kindly press it. Press that subscribe button. Press it there. If you are here with me here, press the subscribe button, please. So try this exercise. Try it for me. Okay. Find your hand here. Find M and number 2. This is my O here. Okay, you are saying, oh, theorem 3 and 4. It means you came late. That's why now, Joel or Sars, it means you came late. For you to be asking theorem 3, please always make sure you come at the right time, please. I've explained theorem 3 and 4 long, around that 4 o'clock. I've explained it already. Please, always come to class early. Anyway, let me try this for me. This one, find your y and find YOZ. Look at it. So try that too for me in the next 2 minutes, 2 or 3 minutes. Try it for me. Try it for me. So you have 3 minutes to do that for me. Please make sure you hit that subscribe. As we are watching it, you will see a button there, subscribe. Press it so that I can get more of my video. Press it, please. So I hope you are done with it. Are you done with it? So how was it? Were you able to find your y and y o z here? Your y is here. Find your y. Your y o z is here. Now for number one, find m. Your m is here. So I think the time is gone already. So what I'm going to do is that make sure you hit that subscribe button. Press it. Understood now? So I will stop here for now. Understood? So in my next video, so let me tell you what I'm going to do in my next video. In my next video, I will do, because this is Circle Geometry 1. You understand? We have just done Circle Geometry 1. We have done 6 theorems. We still have Circle Geometry 2. So in my next class, I will start Circle Geometry 2. And no, I will solve this one first. You understand? You understand me now? And then I will do Circle Geometry 2. Then we will now take past questions. Because my series is here, and I have a lot of past questions here. On WAEC, GCE, JAMB, NECO, and IDCS, we have a lot of questions. So we take a lot of questions on Circle Geometry in our next class. You understand me now? So I will let you know our next class. It is still this week. I will let you know it. So stay tuned. Once again, welcome to Mr. Bam's online class. How do you know we are good? So make sure you like my video, you subscribe to my channel, then you love my video, then you share this video to all other people you can share it to. Thank you so much. Thank you.